Okay, so here we're going to look at how, when we are given an expression or a formula, how we can evaluate that when given different values for our variables. So in this particular instance here, we're given that a is equal to 5, b is equal to 10, and c is equal to 2. Now, just because we've said that a is 5, b is 10, and c is 2, doesn't mean they're fixed. We could change those values if we wanted to. We could say, for example, let a equal 7. We could let b equal 20. We could change these values around for a, b, and c, and that would then change the value of the expression that we would end up getting out of it. But for the time being, we're going to stick with what we've got. So we've got a equals 5, we're going to let b equals 10, and c equals 2. And we're going to start off by evaluating the following expressions. Notice that we've used the term expressions. Now, expression is used because there's no equal sign here. They're all expressions because we don't have any equal signs. And what we're going to do is we're going to evaluate these expressions using the values we've been given, and we're going to substitute these values in for the variables that they're representing. So for 3a plus 7, what we're going to do here, the only variable here that we've got is a, so we're going to substitute our value of a equals 5 in, so we end up with 3 times 5. So remembering that 3a is the same as 3 times a, based on our previous work on algebra. So 3a is 3 times 5, and then plus 7. Now, again, using BODMAS, 3 times 5 is 15, plus 7, and 15 plus 7 is 22. So if we evaluate this expression, 3a plus 7, we end up with 22. Now, again, if we went and changed the value of a, that would then change the value of the expression. But for when a is equal to 5, 3a plus 7 equals 22. Now we're going to move on here. Now we've got a fraction here. Now, again, just as a bit of a revision, a fraction, so something, I use different letters, so something like m over n is the same as m divided by n. So we're going to apply that here. And again, we've only got one variable to substitute in, which is b. In this case, b is equal to 10. So we're going to go ahead and substitute that in. So 3b is the same as 3 times 10, so that's the 3b part, minus 9, and that's all over 7. So now what we do is work this out. So again, bit of BODMAS, 3 times 10 is 30, minus 9 over 7. Now I'm going to run out of space here, so I'm just going to work up here on this side over here. So 30 minus 9 is 21 over 7, and 21 divided by 7 is 3. So again, when b is equal to 10, this expression here is equal to 21. Now, working our way down, we're going to look at this last expression. And here, we're going to use each of the variables, c, b, and a. So just a reminder that a is equal to 5, b is equal to 10, and c is equal to 2. So we're going to substitute these in. So we're going to end up with here 2 lots of, in brackets, so c, which is 2, plus b, which is 10, minus a, which is 5, and then plus 2b, well that's 2 times b, which is 10. Now we can, again, I'm going to apply some BODMAS here, so we're going to do some brackets first. So we're going to leave the 2 out the front. 2 plus 10 is 12, minus 5 is 7, and then we've got 2 times 10 on the end there, which is 20. And again, now what we've got here is we've got 2 brackets 7. Now just like in algebra, when we've got a number and a letter next to each other, that means the same as 2 times a. When we've got a number followed by a bracket like this, it's the same thing. How we would evaluate this is 2 times 7. So when we're evaluating this 2 brackets 7 is 2 times 7, so 2 times 7 is 14, and then plus 20, 14 plus 20 is 34. Okay, now they're all expressions. Notice how we said before they're expressions because they don't have equal signs, and we're just substituting in the given values that we've got for the variables a, b, and c. And again, just to remind you all, we can change the values of a, b, and c. It would just give us different values for the expression when we then evaluated it. Now what we're going to look at is the difference between an expression and a formula. So this time we're given a formula. So given the formula, d equals 20 minus 4m, find d when m equals 2, m equals 5 and m equals 6. So again we can change the values of m, and what will happen is we'll end up arriving at a different value for d. But notice now we're using the word formula, and can you see that we've now got an equal sign and we've got another variable. So what this means is with this formula we can actually work out a value for d. So what we're going to start off here is, if our formula is d equals 20 minus 4m, so therefore d equals 20 minus 4m means 4 times 2, so 20 minus 4 times 2, which is 8, 20 minus 8 is 12. When m is 5, we get d equals 20 minus 4 times 5, or 4 times 5 is also 20, so 20 minus 20 is 0, so we would say that d equals 0. Now that's for when, I should have written d down here, so d equals 12 here when m is equal to 2, when m equals 5, d equals 0. Now when m equals 6, we get d equals 20 minus 4 times 6. So again, using BODMAS, we do the multiplication first, so we end up with 20 minus 4 times 6 is 24. And then some direct number, 20 minus 24 is minus 4. So this means when m equals 6, d equals minus 4. So again, we're just highlighting the difference here between a formula and an expression, and the fact that depending on what value of m we substitute in, and will then dictate the value of d that we then arrive at in the formula. So it's not always the same. All right? We don't always have to use the same values of m. We could substitute any value of m we wanted to into this formula, and we would then arrive at an answer for d.